Let's do this. So here we go. This first one says carbon monoxide reacts with steam to produce carbon dioxide and hydrogen at 700 Kelvin. The equilibrium constant's 5. Calculate the equilibrium concentrations of all species if 1 mole of each component is mixed in a 1 liter flask. Step 1 would be what? Write a balanced equation. So my reaction is going to be carbon monoxide, which is a what? Gas. Reacts with?
Steam should be like H2O gas.
H2O, which is a gas. Is in equilibrium with, what did we say that made? Carbon dioxide, which is a gas, plus hydrogen, which is going to be what? H2. Gas. Is that balanced? 2 H's, 2 H's, 2 O's, 2 O's, 1 C. That's balanced. Yes?
Yeah.
Okay. Now, for my I, they told me that I started out with 1 liter, right? I had 1 mole of each component in a 1 liter flask. Agreed?
That's just 1 molar.
So I have 1 molar of everything. Yes? So I have 1 molar, 1 molar, 1 molar, 1 molar. How do I know which way this shifts?
Good question. Is it because the K is greater than
Yeah.
1?
No.
You're thinking of KSP. The only way I know is I have to solve for Q first and compare it to K. Because you would agree they gave me, these are my initial conditions, yes?
Yes.
So I know that Q is going to equal, this is all gases, so CO2, I'm so sorry, CO2,
Is this parentheses or brackets?
these should be parentheses because these are gases.
Even though it doesn't say.
I know, I'm just going to do parentheses. Over CO, what?
Why are we writing it above the bubble?
I need more room down here.
Oh, okay.
Write it wherever you want to. Times H2O. Okay. Well, what are all of these? 1 times 1 over 1 times 1.
I wonder what it is.
So Q equals 1, right? Q equals 1, which is less than K, which equals 5.1. Agreed? So if Q is less than K, how does that shift?
Right.
That shifts to the right. Because the queen is less than the king, that's right. So it shifts to the right. So if you don't know which way it shifts, that means you have to solve for Q and compare it to K. So you'll be given a K. Solve for the Q. So now I know my change. It's shifting to the right. So my left side, is that going to be minus or plus X? Minus. Minus X, minus X, plus X, plus X.
Oh, if it shifted left, it would be the opposite. It would be plus.
Correct. If it shifted left, it'd be plus X on the other side. So E is 1 minus X, 1 minus X, 1 plus X, 1 plus X. So now I can write out my K expression. So K also equals parentheses CO2 times parentheses H2 over parentheses CO times parentheses H2O.
It's the same.
So I'm going to sub in, it is the same, but I'm just writing it out. So 5.1 equals 1 plus X squared. Are you okay with that? Yes? Over 1 minus X squared. Yes?
Oh.
Right?
Is that? Oh, that's 5.1. I thought that said SI.
It's 5.1. What do you need to do to both sides? Take the square root. Square root this, square root that. So the square root of 5.1. What do you get for that? The square root of 5.1.
Who's gonna do it? How do we get there? Emily, you got a calculator. Oh, I see. Mikey, somebody.
I'm gonna be honest, my calculator died, so
Yikes.
I forgot to charge it. My bad, guys.
2.258 or 2.26.
2.26 equals 1 plus X over 1 minus X. Right? Multiply over 2.26 minus 2.26x equals 1 plus x.
This is literally algebra.
I know, it's just algebra at this point. Solve for x, and x ends up being 0.387 molar. 0.387 molar. So now I have to calculate the equilibrium concentration of all species. So my CO, right, is going to be equal to H2O, right? Which is going to be 1 minus 0.387, which is what? 0.613 molar. These really should be brackets because it's molarity, but
0.387 is just how much each side changed, correct? Like, how much the concentration changed. Like, what is it, I guess? How would you describe what the x is representing?
I'm figuring out the change.
Yeah, okay, that's
And these are
Yes.
1.3.
So my concentration of CO2 should equal concentration of H2, which is going to be 1.387 molar.
Doesn't matter if you use brackets or not.
I mean, it didn't say KP, but because these are gases, it's really because of concentrations, it should be brackets. All right, this next one. This is probably the most important one we'll do. Gaseous NaCl decomposes to form gases NO and Cl2. At 35 degrees Celsius, K is 1.6 times 10 to the negative fifth. In an experiment where 1 mole of NaCl is placed in a 2-liter flask, what are the equilibrium concentrations? Step 1. Write the equation. My reaction. So I have NOCl, which is the gas, is in equilibrium with
NaCl.
NO plus Cl2.
So this is going to be balanced.
Going to need balanced. So that means I have to put a 2 here,
Did you take factual time?
2 there. So that's my R. Initial. It says I have 1 mole of NaCl in a 2-liter flask.
So 1
1.5 more.
Excuse me during dog and pony?
Oh, that'll work. Let's plan on that.
What's this mean during dog and pony?
Second period.
Monday?
That's fine.
0.5.
Yeah.
1.5
Okay.
yeah.
I want you guys to think about if you could get some representatives, even if it wasn't you guys, but like maybe some of the kids, to do some demos or something at Melrose at STEM night,
Okay.
February 21st. I'll email you guys about it.
Okay. Cool.
But I think that would be good because we've done that for years and I think we
Okay.
appreciate it if you guys did some stuff too.
Okay. So 0.5, it's a decomposition.
Are you doing Sasha Berry Kim today?
I'm doing the first 2 pages with regular.
Of Sasha Berry Kim?
I'm doing 10H with honors.
Did you already do Sasha Berry Kim with honors?
No, I have not.
It's decomp, so probably zero.
Why are you going backwards with regular and honors?
I don't know.
Okay.
I have no idea why I did it like that.
No, you're okay.
0, 0, because this is decomposition, right?
Yeah.
So I'm starting with nothing on the other side. Change is, it's shifting to the right. So what's my change going to be here?
Minus x.
No.
What? What should you do?
2x.
Minus 2x. This one's going to be plus 2x. And this one's going to be plus x. You have to watch out for coefficients. All right? Watch out for coefficients.
Wait, why are the other ones 0 K?
So like, it's like a CL2, it's still just
Right, only the coefficients. Change it. So my E is 0.5 minus 2x, 2x, and x. Now, we're going to write our K expression.
Yeah.
So K equals concentration of NO to the second times concentration of Cl2 over concentration of NOCl to the second. So, sub in what you know. 1.6 times 10 to the negative fifth equals, this is going to be 2x, that whole thing squared, times x, over 0.5 minus 2x, that whole thing squared. Here's the shortcut. Because if there wasn't a shortcut here, you'd have to do quadratic formula. Here's what you need to know. K is really, really, really what? It's really small. Agreed? When K is small, it's barely gonna go which way? Towards the what?
Right?
It's barely gonna go to the right. Yes? Which means your reactants are pretty much not gonna change at all. Yes? So this is called the 5% rule. That means if the reactants aren't gonna change, then this X on the bottom is gonna go to what? If the reactants aren't gonna change, it goes to 0.
What's this one with this?
So this X would go to 0. You could solve it with quadratic formula. You could solve it with this going to 0. The answer will be less than 5% different.
Oh.
So this X, because the K is small, this X goes away because the reactants aren't changing because K is so small. So that's the big key. You want small Ks. All right? You want small Ks when you have something like this. So this turns into 0, right? So now
Just the 2x, not the entire thing.
just the X. Just the X. So now, this makes it a lot easier. 1.6 times 10 to the negative fifth equals 4x cubed over 0.5 squared. Do you see how much easier that makes it?
Do on the AP thing, you like write something if you use that. Like,
No.
so it- okay.
Well, no. Well, no, it's going to 0. Yes.
You get the same answer by getting the quadratic formula.
It won't be exactly the same, but it'll be less than 5% different.
Okay, so I could do the quadratic formula.
If you want to. If you want to do the quadratic formula, I'm completely cool with that.
Okay, I just don't want to like do that in the wrong place and mess it up.
It'll always be on the bottom.
What's our
Right, but like, when do you know?
Yeah, what's the
when
cutoff?
it's
yeah, what's the
small?
K value?
I would say any K less than negative second or more.
We trust.
So
Yeah, like, okay.
So negative second or less than negative second?
I would say negative 3 or more. So any K negative 3 or more to the negative third is too small. Okay? So negative 3 or less. It'll be obvious. The AP test isn't going to give you something like borderline,
That would be so mean.
right? Or do a quadratic formula, but it's just going to take more time. Or graph it. So solve for X. And once you solve here, X ends up being 0.01 molar. Someone want to put that in their quadratic formula? Do it.
Yeah, that barely changed.
Yeah, it barely changes. It barely changes. Did anyone put in the quadratic formula to check it? Okay, you can check it. It's going to be the same thing. So then what are the equilibrium concentrations? Well, Cl2 is going to be 0.01 molar. NO is going to be 0.02 molar because it's 2x, right? And NaCl is going to be 0.5 minus 0.02. So essentially, NaCl is still just going to be, with sig digs, it doesn't change, right? With sig digs, it doesn't change. Because it's the least amount after the decimal and you subtract,
Oh, so yeah. that
right?
makes sense.
So you see how that doesn't
You're like
change.
technically 4.4.
Technically, it's like 0.44, like 0.498 or something, right? But you can see that it doesn't change. So those two ice problems are really important because we didn't do one where you had to solve for Q first to figure out which way it shifts. And now you see the shortcut. If K is small, the X on the bottom goes to 0. Your life is beautiful. Now you should be able to do every single problem on